Okay, so welcome to this video. In this video, I am going to talk about the basic idea of pathfinding, and how would you know if if you're going from point A to point B, if such path exists or not. I guess the application side of thing would be that if you're making a video game, right, and you want to move from point A to point B, is it possible to do that? And that's that. In this video, I am not going to be talking about the shortest path or the shortest distance to go on, from point A to point B. I'm just looking at, is it possible from, going from point A to point B. So if you look to your left, I have this, illustration on, let's say, we have Bob here, and Bob wants to go to the village. In this case, it would be at the point Boo. And for your information, each point we call it, we just call it nodes. So this would be called a node Boo, a node Foo, and then we have normal, node A, node B, node C, node E, node D, and so on. So we're just gonna refer that as a node. A point is a node, and that's that. So let's get back to the problem. We were trying to find out if Bob can go to Boo, or in this case to the village. And obviously, if you look at it, he can. But how so? How does it work? Right. For obviously human, we can literally just tell, right? You go from A to C, and then to Foo, and then to Boo. So it's not it's not a difficult task, but for an AI, right? How would you do that? How would you instruct it to go from from A to C, right? When this after that, and go to Foo and then Boo. So we're just gonna look at the basic concept of that. So but again, we're not gonna go over how is it what is the best way to go on about this, right? We're just looking at, is it possible? So we don't care if it's gonna go A, B, E, D, C, F, Foo, and Boo. We just make sure that it actually does reach the destination, right? We're not caring about the optimization part of it. Okay, let's take a look at the code here. So essentially these line of codes, right, they are what you see on the left, on your left, I guess. It's just different node has its own different ID. So we're making sure that each node has its own ID or unique value that we can use to compare. And then I'll go on about it, why we need that. The neighbors. So we're just saying in the neighbors. So without any neighbor, so let's take a look at this. Without any neighbor, something like this, and let's say this is A, and we're going from A to something else somewhere. Without any neighbor from A to anywhere, it means that it's not doing anything. So we need to make sure we have neighbor, and I'll go on about this again in the actual the algorithm itself. So essentially, this is just setting up the stage as initialization process of it. So we have these nodes, and then we have the neighbors, and here we're saying we want to move from node A to node Boo. It's gonna give you is it possible, or does the target exist? In this case, if you try to run it, it says the target exists. So we're just gonna take a look at how does it work exactly, basically. Yeah. Right, let's go to the actual code itself. So I assume you have some experience with object-oriented programming. So we have a class called node, the ID, right? And then the ID is set when you have when you create a new object or a new instance in this case. So node A and 1 and the value there, etc. We have two lists, explore and next nodes, and then I'll talk about it. What are these two lists are for? And here will be the algorithm itself that we're going to be taking a look at. So it's quite a bit. Okay, now I'm just going to leave that blue illustration up just for you to see here what I mean by it needs to have a node, a neighbor, not a node. Whenever we say A right? Node A dot 2. We want to make sure that node A does actually have the neighbor, because again, if you look at here, right? Say I'm just gonna change the color here. Let's say here at A here, right? So you see the black point there, black dotted point, without any association to any other node. It doesn't matter where you want to go. You won't be able to find it. You want to be able to go through each node and find the target. So essentially, we're saying that if it doesn't have a neighboring nodes, then we just don't care. We just ignore it and skip it, and we can tell that for sure it is always gonna be false. It doesn't exist. So, and that's that. I mean, don't worry about it too much. Alright, let's take a look here. If you look to your left, I have this explore and next node written there. They are there just to keep track of what the algorithm is going through. My best advice on learning any kind of algorithm, whether it is pathfinding, sorting, any kind of procedural way of doing things, always try to write down and see yourself. Even if you watch this video, right? If you're not experienced with this, you might get confused and stuff like that. And so the best way to do this is to go through yourself, write it down, repeat it. Repetition is the best way of learning things in this kind of way of doing. And so just keep doing it. But anyhow, so we're just gonna keep track of this and see what's going on basically behind the scene. Right. The next node is essentially this keeps track of what to go next, which node we want to explore next. Now it said this dot add this is essentially add itself. So when it add itself again, we are starting at node A, right? So this is itself. So essentially it's the initialization process, right? This only run once because again it's gonna go through here, which this is the while loop, but essentially it's gonna explore the first node, which is Bob, and in this case it will be node A. Okay, it checks is the next node that we're gonna be exploring empty. If not, then we just run this. If it is, then we're just gonna skip that. But in this case, we're gonna it is not empty because we have just added, right? Makes sense. Okay, now to be explored node is essentially the first item in this node. If you have worked with queue data structure, is essentially the same like that. So we essentially get the first item in the list. If you look at the list here, the first item is this one, so we'll be using that. Then it would remove that because once the node is we are exploring, we do no longer need that because we have already been explored. So what I'm gonna do is I'm just gonna close it like so. So this the clause here, just to keep track of it, it's gone now. Just imagine the next node is nothing, it's empty now, right? The clause there is just to keep track, what were the previous and stuff like that. But we're not gonna do anything. And again, if you go on about this, I'll show you what I mean by that. Okay, if the target is found, basically it's gonna check is this. Then we have this clause, is it the target? It's not, right? It's not the target. If it is, we can literally just say the target is found. Then it will try to add to explore. What this means that this has been checked. Okay, node A is already checked that it is not the target. So to not repeat that again, we want to keep track of that. So we go here and add to explore list, which is gonna go up here, and that's that. Then it's gonna look for its neighbor. So what this is, for each group, it's gonna go to each neighbor. Node A has has two neighbors. They are B and C. So it's gonna go first. I go to B. So now let's assume that we have B. Okay, has B been explored? What this function does is, so let's go down here a bit. This function go through the explore list, find any node that has the same as B in that So what this means is, it go here, right? If you look at my pointer, and it check if there is any node B. In this case, it hasn't, because we have not explored that yet. So what it says is it's gonna do this logic here, add neighbor. So just gonna add this to here. Okay. Now it's gonna go to the next one, which is what's the next neighbor is C. Oh, and this one too. Make sure that B is not doesn't exist already, right? Because we can have a duplicate node. So if B is already here, we're not gonna add it, since we know we're gonna be exploring that later on. But in this case here, right? It would be this would be true, and then it would be add. Okay, let's go back a bit. Now C, right? At node C, has C been explored? If you take a look here, no, it hasn't. Is C also exists in the next one, or the queue? No, it is not. So we're just gonna add that. No C. Right. Then this for loop is done. Go up. Check it here again. Okay, is this empty? So is this list empty? No, it is not. So I'm just gonna keep doing it. Okay. I'm just gonna go a bit slower and then faster and faster, just because there are a lot of steps you have to go through, and I don't want to waste your time, I guess. Okay, so to be explored node, right? Again, it's gonna get the first item on the next node, and if you look at the list here, we know that the next one is B. Okay, and then it cannot remove it, so we know that we're doing with B. Is B the target? It is not. Skip. B is now has now been explored. Now B is already checked that it is not the target. So B is added there. Go through each neighbors of B. The neighbors B are what? It's A and E, right? Has the A been explored? Yes. Right? So this would be true. So it would skip, and it's not in the queue. Okay. So A doesn't exist here. A has been explored. So this is checking for has not been explored, which is false, and obviously it's gonna be false, and this is not gonna work. So yeah. So we skip. Right. We now add E. Has E been explored? Check for E. Is there? No, it's not. Is E in the queue? No, it's not. So we reject it. We're gonna add that. Not E. Yeah, that's it. Okay, and it keeps doing this until you get the target. So I'm just gonna go through this faster and faster. Okay. So yeah, we're done with E, and then we're gonna go up here, right? We're gonna go to the next one, which is C. Okay, we're gonna cross C now because the remove line there. So right, remove C. Is C the target? It's not. Now we add C to the explore list here. Okay, it's gonna check for C's neighbor. So what are the C's neighbors? C is here. The neighbors are A. And again, if you follow the logic here, A has been already explored, so this is gonna be skipped. So A is not gonna be there. D, has D been explored yet? No, it's not. So node D is added. Then we're gonna go node F. Has F been explored yet? Nope. It's gonna go F here. Then you're gonna check for node foo. Node foo hasn't been explored yet. Foo. And then we're done with that. Gonna go up again. Check for the next one, which is E. Right now we cross it, and then we check if E is the target. No, it's not. So we add that to the explore. So we check already. That's not the target. Now we're gonna go to the neighbor. So where's E? Okay, E is here. The neighbors are B. Has B been explored? Yes, B is already exists. E again. Go D. Has D been explored, or is D in the list in the queue? Yes. So this won't do anything. And has D it has G now. So E, right? So now it's G. Is G exists here? Nope. Here? Nope. So we're gonna add it. Then we're done. Next is D, right? So D is now here. Remove D. Add D to explore. Well, we check first, but we know that it's already no. So we check D is not a target. So now we know that it's not a target, so we add it. Okay. Then we check for the neighbor. Okay, where's D? D is neighbor E. Okay, E has been explored, and we don't care that, so we're not doing anything. And C has already been explored, so we're not doing anything there. So we're done. Okay. Next is F. Okay. F again. Go up here. Oops. F here. Then we remove it. So we're just gonna close it. Close F. Okay. Then we check is F the the target. No, it's not. So we're gonna add F here. So I'm just gonna put it on the right side here. Note F has been explored and it's not. And then again, it's gonna go to the neighbor. F has has two neighbors, H and C. C is already exists because of this. Now we're gonna add H. Note H here. Okay. Now, next. Okay, next is node foo now. Node foo up here, and then we're gonna do the same thing. Node foo. Close it because we remove that. Then is node foo is the target? No, it's not. So we know that node foo is now explore. Then it checks for the neighbors. So who are the neighbors? Boo and C. C already exists here, so we're gonna add Boo. Node Boo. And essentially node Boo is the target, right? But it doesn't check, right? If the neighbor, the immediate next neighbor is the target, it will check it later. Okay, now we're done with Foo. Now let's add G. Okay, where's G? G is right there. Oops. And right, the same thing. We cross G out. We add, now we check if G is the target. No, it's not. So we add it to the explore list. Now what are its neighbor? G has E. E has already been explored. G has S. S has not been explored yet, but it already exists to the next queue. So we're not gonna do anything to that, and we're done. Then we have node S, right? Node S, we cross that out. Now we check for if node S is the target. It's not. So we know that it is not a target. So we add to explore node. So we're not gonna check it again. Now who are the neighbors? The neighbors are G and F. Is G has G been explored yet? Yes, it is. Has node F been explored yet? Yes, it is. So we're not gonna do anything to them. Then now's the magic, the part, the final part. Go up here, right? Now we are at node Boo. We cross it because remove it here. Is Boo equals to Boo, right? Is Boo equals to the given target? In this case, the ID are the same. Then we print out the target exists. Then we get the hell out of here. We're done. Right. We're essentially done. And that's it. That is the that's it. That would be how you find it. Yeah. And that's how the algorithm works. I guess if you want to practice more, instead of having to write down each step here, find out the way you can print it out all the step here and see if you're doing it right. Try the writing by hand, then try to print out the node, and make sure you have this result and the same outcome basically. But essentially this is it. This is how searching, pathfinding works. It would go to each node, look for the next one, right? Is the next one the target? No. Okay, check for its neighbor, then add it, do something like that. Yeah, just what I have talked in this video. If there is any question, feel free to comment. I'll try my best to answer. But thank you for watching, and I'll see you in again in the next video. I hope I do plan on making using this in Unity to show you that, you know, or maybe I'll probably work on the A-star pathfinding algorithm, and it's just gonna go through that. Then I'll go through make a video on how would you use that in Unity or any kind of project actually, and then, you know, move something around. And yeah. Anyway, again, thank you for watching, and I'll see you in the next video. Bye now.